This is the first revision video for Chemistry Unit 4, and this is on atomic structure, including electron structure. The first thing that you basically need to recall about the structure of an atom are the name of the three subatomic particles involved. You've got the proton, the neutron, and the electron. Proton and neutron are encased in the nucleus, which is at the centre of the atom, and the electrons orbit in shells surrounding the nucleus. There are two more things that you need to know about these subatomic particles, and that relates to their mass and their electrical charge. In terms of the mass, it's only the subatomic particles contained in the nucleus, namely the proton and the neutron, that have any charge, any mass. Sorry, they both have the same mass. They both have a mass of 1. So if you take the example of lithium that you saw in the previous slide, lithium having atomic number 3 and a mass number of 7, it contains 3 protons, 4 neutrons, giving it atomic mass of 7. In terms of charge, the two subatomic particles that have charge are the proton and the electron. The neutron, as its name would suggest, is neutral. It has no charge, it just gives the atom more mass. The proton is positive, which means overall the nucleus is positive and the electrons are negative. That's why the electrons are drawn towards the nucleus, although because they're moving so quickly they never meet with it, but they are drawn and attracted towards the nucleus. So if you were to look at the periodic table, what you'd expect to see for any of the elements would be an entry such as this one that we have on the right for carbon. Carbon's atomic number is 6. The atomic number relates directly to the number of protons that an atom has. The proton number, or the atomic number, is distinct, i.e. no other element has the same proton number as carbon. It's what makes carbon unique. The other number on this slide is the mass number. Now this is not necessarily unique and can be changed, but in the case of carbon it is the only one that has a mass number of 12. From this entry in the periodic table you can pretty much determine anything that you like about the atom. The proton number tells you the number of protons, as you would expect, but it also tells you the number of electrons contained within this atom. So in this case what we have here is 6 protons and 6 electrons. Atoms are neutral overall, so if they have 6 positive they must have 6 negatives. The other thing we can determine from this is the number of neutrons. Its mass, overall mass, as I stated before, is 12, which means that it has a mass of 12. If you take away the number of protons, the atomic number, that will give you the total number of protons. The reason for that is that the total mass, 12, take away the mass of the protons, must then give you the total number of neutrons. So if asked for a question, in an exam question, how many protons, electrons or neutrons do you have? In the case of this one you have 6, which comes from the proton number. You have 6 electrons, which again comes from the proton number. And you have 6 neutrons, which comes from the mass number minus the proton number. Another thing you need to be aware of when considering the basic structure of an atom is something called an isotope. This is hydrogen. Hydrogen is the simplest version of any atom. It simply has 1 proton and 1 electron. But there are 2 different versions of hydrogen. This one here is called deuterium, and this one here is called tritium. The reason that they are still hydrogen is because they all have 1 proton. That is distinct, it does not change. That's what makes them hydrogen. But the 2 isotopes both have a differing number of of neutrons. That's what makes it an isotope. So an isotope changes number of neutrons, as stated down here. Another example of isotopes is chlorine. Chlorine has two major isotopes. This one is chlorine 35, which contains 18 neutrons, and this one is chlorine 37, which contains 20 neutrons. There are also different isotopes of carbons, all of them containing 6 protons, but having a differing number of neutrons. Carbon 12, which is the most common, carbon 13, and carbon 14, which you might have heard of, which is used in radioactive carbon dating. So as previously stated, for any atom, using the periodic table, you can figure out how many protons, how many electrons, and how many neutrons you have, simply by using the atomic number and the mass number. As you can see, as I stated here, protons, there are 6 in carbon, 6 electrons and 6 neutrons. That can be seen in the diagram here. The blue neutrons, the black protons, and the 6 red electrons orbiting the nucleus. We describe this structure as being a 2-4 structure. That's because there are 2 electrons in the first shell and 4 electrons in the second shell. The arrangement of the electrons around the nucleus is not random either. You basically have shells of different energy levels that can take a certain number of electrons. The first shell has room for 2 electrons, the second one has room for 8 electrons, and the third one has room for 8 electrons as well. Because the atom that we're looking at here is chlorine, there are actually 7 electrons in its outer shell. Because of this, chlorine actually has 1 space in its outer shell. Basically, whenever you're doing atomic and electron structure, the sequence that you must remember above all others is the sequence 2, 8, 8. This tells you the number of electrons in each shell and is absolutely vital for you to work out where the electrons are positioned in any atom. So finally, here is the periodic table. You'll notice the mass number and the atomic number of each of them. And take, for example, sulfur here. Sulfur has a mass of 32 and an atomic number of 16. So if we apply the 288 rule, sulfur, because it has 16 electrons, which I can find from its proton number, will have 2 in the first shell, 8 in the second shell, giving me a total of 10, and 6 in its third shell, giving me the total of 16. Beryllium here is an easier one. 4 is its atomic number, so it's got 4 electrons. That will mean there'll be 2 in its first shell and 2 in its second shell. It's important to note that electron shells always fill up from the inside out, so if there are more than 2 electrons, there will always be 2 electrons in the first shell. You can apply this procedure to any of the first 20 atoms, and you could be expected to in a test, going from hydrogen with just 1 electron right through to calcium with 20 electrons. If it was calcium, there'd be 2 in the first shell, 8 in the second, 8 in the third, leaving 2 in its fourth shell. Incidentally, there is a little shortcut that you can use to figure out the structure of electrons in the periodic table. At the top of the periodic table, we have the group that the atom belongs to. That tells you how many electrons are in its outer shell. So all of the group 1 alkali metals all contain 1 electron in their outer shell. As we saw before with carbon, it contains 4 in its outer shell, therefore it's in group 4. And as we saw with chlorine, that contains 7 in its outer shell, so it's in group 7. The period that the element belongs to, or the row that it's in of the periodic table, that tells you how many shells it has. Oops. So we've got period 1, 2, 3 and 4 that we need to be concerned with. The one that people forget is period 1. It's small, It only has 2 in it because of the 2 electron spaces in the first shell. If you wanted to use this to, say, for example, figure out the electron structure of silicon, you would know that silicon would have 3 shells and it would have 4 in its outer shell. So its outer shell would have 4, and because its outer shell's got 4, its inner 2 shells must have 2 and 8. That concludes my first revision video for C4. If you have any further questions, you can either see me, Mr. Clee, or any of your science teachers. Thank you.